So with the second part of P5 and factoring completely, you kind of did it yesterday a little bit to a certain extent whenever you had your difference of two squares. There were a couple on your assignment that were, it was a perfect square or difference of two squares, and then after you factored it, one of the two was also a difference of two squares. So if you didn't get that, know that that is going to happen. So whenever you have to factor any polynomial, okay, first thing, like we talked about yesterday, is, bless you, is does the polynomial have a GCF, and if it does, factor that out. Okay, because if it has a GCF, it's going to make everything a lot easier to work with because your numbers are going to be a lot smaller. Okay, because you're factoring out a value. Once you get to that point, then it becomes how many terms do you have? So if it's 2, it's pretty simple. If you factored something out, or even if you haven't, if it has 2 terms, then you're looking for a difference of two squares, a sum of cubes, or a difference of cubes, like we had yesterday. Okay, so if it has 2 terms, that's the first thing you're thinking of. If it has 3, as far as a special case, you want to see if it's a perfect square. So is the last number a perfect square? If it is, what is the square root of that value? And is the middle term double that number? So like if it would be 4x squared, let's see, let me think of something. Like if we have 4x squared plus 8x, actually let's just go x squared because I know I can make it work, plus 16. 16 is a perfect square. From there, you have 4, okay? 4 and doubled is the 8, so if that middle term is a perfect square or a square root and doubled, then it's going to be a perfect square. If not, you're just going to factor it like normal, just like we did yesterday. Then, if you have 4 terms, try factor by grouping. Now, if you're going to do factor by grouping, you have to make sure that you have all the same variables, and that'll make more sense in a minute. And then check to see if any factors can be factored further. So if I have 2x to the third plus 8x squared plus 8x, does 15 have a GCF? Is there something that I can divide each term by? X and what else? 2x. So if I factor out a 2x, I'm left with x squared plus 4x plus 4. Now, the 2x is out there. Now I want to look in my parenthesis. Can I factor this even further? Okay. Your fail-safe is always to look and do your x like we did yesterday. Are there 2 numbers that can multiply together to give me 4 here, and then add to give me 4x inside? So if I go 2x, x plus 2, x plus 2. Now, I'm okay with you leaving it like this. This is a perfect square, so if you want to write it as 2x times x plus 2 quantity squared, that works as well. Now, on 16, you have 8x to the 5th minus 18x. You only have 2 terms, so what are we probably going to be looking for? One of 2 things, right? Either a difference of 2 squares or in this case, since it's a subtraction, difference of two cubes. So first off, can I factor anything out? Do I have a GCF here? Is there anything that I can factor out? X? Is there a coefficient that I can factor in? 2x. So I have 4x squared, or fourth, excuse me, not squared, minus 9. Is what's in the parenthesis a difference of two squares? Is 4 a perfect square and is 9 a perfect square? Yeah. So that means I can factor that. So what number times itself will give you 4x to the fourth? 2x squared. What number times itself is going to give you 9? 3. It's a difference of two squares, so that means my terms are the same. But one's positive and one's negative. Can anything else factor? Can I factor out the 2x? Is the 2x squared minus 3 right here, is it a difference of two squares? No. So am I done? Yes. Now, on 17 and 18, they're both set up pretty well the same way. What do you notice between... How many terms do we have, first off? 4 terms. So if we do it by grouping, but what's the problem with doing it by grouping? What do you notice about some of the terms? Yeah. Well, yeah, they don't group very well. Why don't they group very well? What kind of throws a wrench into the plans on like 17? The a squared. Okay, so if you have two different terms and you only have, like in this case I have x squared minus 25a squared plus 8x plus 16, there's only the one a. All I'm going to do is I'm going to take this and I'm just going to put it kind of over to the side, and I'm going to factor x squared plus 8x plus 16, and I'm just going to have the minus 25a squared over here. Because what I want to do, I want to look just solely at this part here. Can I factor, can I rewrite it? Okay, all I'm doing really with factoring is rewriting it. Can I factor x squared plus 8x plus 16? Somehow, some way. Say what? Okay, so you want 4 and 4? So do you want to do the x or no? Huh? Okay. Well, you told me the answer, that's why I'm asking. Yeah, if you know that it can. Okay. Come on now. So you just want to do this? Is that what you want to do, or you don't care? Huh? You're driving this bus. I mean, we can go like this. We can go, well, that's 16, and that's, no, what is it? Negative 8, positive 8. We can get the wings right here and go 4 and 4. Now, we can rewrite this as x plus 4 squared. Now, we don't want to forget about the negative 25 a squared. Now, we're not done. What do you notice about these two things? They're both squared, right? What do you notice about that sign right here? It's a subtraction. So what is this actually? Isn't this just a difference of two squares? Yeah? So it's a difference of two squares. So what I'm going to have here is I'm going to have, in a parenthesis, I'm going to have x plus 4 minus 5a times x plus 4 plus 5a. Okay, all I did was just rewrite the x plus 4. That sign didn't change. The sign that did change was the sign that was after, bless you, after the subtraction sign. Okay? So just because you have two different terms, like in this case the a and the x, because it's going to be a difference of two squares, it's still two squares even though it looks kind of funky. Okay, and we can still separate it out that way. Factor expressions containing either fractional or negative exponents. Okay, what you're going to do is you're going to remember that when using a GCF, we take the smallest power of each variable. Okay, so notice here we have the x plus 1 to the negative 3/4 power. And then we have x plus 1 to the 1/4 power. So of these two powers, which one is the smallest? Is it negative 3/4 or 1/4? Negative 3/4. So essentially what I'm going to do is I'm going to divide each one by x plus 1 to the negative 3/4 power. So since we're looking at the smallest term, my GCF is the x plus 1 to the negative 3/4 power. Okay, so that's what I'm actually pulling out of each term. So that's going to be outside my parenthesis. And then I'm going to have my grouping. So if I look right, if I look right up here at the top, what do I have left? What's the only thing that I have left? X. Now, it's going to be a plus, right? Because it's a plus here. If I factor out a x plus 1 to the negative 3/4 power, what am I really going to do right here with my two exponents? It's dividing, right? So what am I going to do with my exponents? If I would have had x to the first over x to the third, what would I have done? I would have subtracted them, right? Okay. So you're still going to do the same thing. So what is 1/4 minus negative 3/4? 1. So that means I'm going to leave the x plus 1 and I'm going to take it to the first power. Okay, whatever number you get right here, I'm just going to put it as my power. Okay, because whenever I multiply, if I would distribute this all the way back through, like, and I wanted to check it, I would end up with 3/4. I would just be multiplying those, right? And so if I'm multiplying, I'm adding my values. Well, negative 3/4 plus 1 gives me the 1/4 that I started with. Okay, since they're pretty well the same, What's the only thing I'm left with up top? So x minus 1 to the negative 1/2 is what I'm going to have out, and then I'm just going to group it. What's the only thing I have left in the first part? X plus, what's 1/2 minus a negative 1/2? 1 again, right? So it's just going to be x minus 1 to the first power, and there's my answer. Bless you. What did I do? From the white one to the yellow one. Combine like terms inside. Why was I able to put the x minus 1 to the 1/2 on bottom? Because it has that negative power, right? So we can just slide right under. Again, I'm okay with either one. If you want to put it the one in yellow, that's fine. You want to keep it in the one in white, that's okay too. I would even be okay if you would make it 2x minus 1 on the inside, okay, of your grouping symbol, because that would be the same thing.